Hello everybody, welcome to episode number 17 of the BIVBlog, Benedict's IT video blog. My name is still Benedict Stockerwand, and today I want to show you how to create installation images for the rescue and network install system we've built in the previous couple episodes. This is supposed to be the second to last episode in this series. There will be some more stuff on what you can do after installation, but that'll be a separate episode. This time I want to show you how to create an image, that's fast and convenient to install, and what sort of pitfalls you might run into. So, for example, I use FreeBSD in this time. FreeBSD rather than Debian that we've used all the time so far. First of all, because, well, I want to show that I can do other things than just Debian Linux. And second, because it allows me to show you a couple problems that can occur with images once you install a different operating system than the one you use on the rescue system. So we use FreeBSD. By the way, it's the fastest one to install, but that shouldn't be much of a problem because I'm gonna fast forward these installation things in the video anyway. Let's take a look. Okay, first trick to do is use a virtual machine to install things. It just makes life easier. In my case, I'm using Xen here, and I've already set up a Xen configuration and a link to the ISO image that I want to install. But I still need a virtual disk to install to. And in the configuration, this one is called HD0, and the way I install is this, DD, the data duplicator. Input file is dev0, output file is hd0.image, which is the name I've configured for the disk image. And now comes the funny part. I say block size equals 1 byte, I do a count of 0, and I do a seek equals 1 gigabyte. And what this does is it creates a file hd0.image because it doesn't exist yet, and then it uses a block size of 1, and it writes 0 blocks of size 1, but before it does so, it seeks to 1 gigabyte or 1 giga blocks. That's why I have to use the block size of 1 in that file. The result is I get a file hd0.image which is 1 gigabyte in size. But if I check how much memory it actually uses in the file system, nothing, because the file is set to be the size, but it's a sparse file, so whatever hasn't been used is actually not allocated in the file system, so it doesn't use up any space and makes it faster to copy afterwards as well. This is one of the reasons why I like virtual machines for this. I can choose whatever virtual disk size I want, and the smaller the disk is, the faster the imaging goes afterwards. And another good thing is this one is implicitly initialized with zeros. So if I had to use a physical disk instead, I'd have to erase the disk beforehand so things compress properly and there's no confidential data leaking into all sorts of machines that I install the image on afterwards and whatnot. So let's start the virtual machine. Start Xen imager. This is just a little script I've written to make things more convenient for myself. It's not standard. And we see FreeBSD booting. Takes a couple seconds. Okay, now I do a fairly standard installation. I don't need games, I don't need 32-bit libraries, I don't need ports. I use ZFS as the target. Okay, a swap size of 2 gigabytes when I have a 1 gigabyte virtual disk. Doesn't make that much sense. I don't use any mirroring. That's a topic for the next episode. And here's the disk I use. By the way, in case you wonder what this ADA0 is, that means the A stands for AHCI or SATA disk, DA is direct access, which means disk, and 0 is the number. So this is the FreeBSD equivalent of def SDA on Linux. Install things there. And yes, I'm serious about it. And now things install. This takes about a minute or so, so it's really fast, and it just gives me a chance to explain what's so special about FreeBSD, which is kind of convenient in this case. What FreeBSD, the installer, does, it just extracts various tarballs, in this case only the base system and a kernel, into a pristine file system, or ZFS file system in this case. And that means all the disk space that isn't used is still broadly, except for some minor exceptions maybe, initialized to 0 from the imager. If I was to use some sort of system that used network installation, so it would fetch packages across the internet, put them in the file system, then extract them, then delete the package files, we might have some sort of crud in the disk image which we might have to get rid of. And I'll show you later on how to do this. Not a problem with FreeBSD, but might be a problem elsewhere. So we need a root password and network configuration. Okay. Yes, I do use IPv4. I use DHCP. And yes, of course, I use IPv6. What do you think? Yes, I do use auto configuration, except there is no advertising router in the network here, so this will take a bit of time to decide this isn't worth it. And I don't configure the resolver at this point. Yes, UTC and UTC, yes. And yes, I do want the SSH daemon. This introduces a security issue we have to take care of, and I'll show you in a moment. But we install that. No, we don't need extra users, and that's it. Do I need an additional shell? Actually, yes. Now, the problem with imaging and the SSHD is that if I install the SSHD, for example, on Debian, which always starts everything you install right away, you might wind up with an SSH host key. And if you use the same SSH host key from the image on all machines you install with the image, you have a bit of a security issue. So what you want to make sure is it's in mount, in this case etc, no, mount etc, no, where is it? Where's the root file system? It's unmounted already. Oh, so it has been remounted. You want to make sure that in etc SSH there is no SSH host key at this point in time. And with Debian you want to make this sure, otherwise you want to check that there isn't FreeBSD in this case. It doesn't start, or it doesn't create the keys until the system reboots and the system is first started. So at this point I'm fairly happy, but still what I'm going to do is I reboot the machine and see that it comes up properly. It's just common sense to check these things out first. Okay, and here you already see generating RSA1 host key. That's SSH host keys for all sorts of stuff. And the first thing you want to do at this point is actually remove them again. So at this point we can configure the system to our heart's content. Just keep in mind that all the configurations you do here will apply to all images. And in the next episode, I'll show you how to do some configuration for a specific copy of the image once you install systems with it. But that's quite a lengthy topic by itself. So we do this in a separate episode. Anyway, once I'm happy with the system, and I might have set up things like, for example, the resolver or the NTP configuration, you might do that. You might also do that using DHCP, or let's say do something for the boot process, say auto boot delay equals 2, so the system doesn't wait for 10 seconds for me to decide if I want to do anything unusual, but rather just 2 seconds. And eventually I just power the machine off and create an image. Which is fairly simple if you use a virtual machine, because I've already used an image. And important thing is here to use a raw image rather than some QCOW2 or whatever, because this is copied verbatim to the destination machine. Now what I could do at this point is something like gzip -9 input is hdo.image, and we put that to serve nfs install images and demo.image.gzip. Problem here is that'll take what, 15 minutes or so. So what I do right now is I just copy that thing copy that thing to the installation image directory, and then start a target virtual machine to see how this works. And I've already set up a target or a virtual machine called PXE test. Again, we have to create a disk image, and it has to be at least the size of the image I want to install, but in this case I just make it 100 gigabytes in size, so we can see what happens if we install an image that's smaller than the target disk we actually install it to. And it's start xen again, PXE test, and we boot into our virtual system. Installer, and now we wait for Linux to run. In the meantime, a couple things that I've changed to the makefile and installer script from the previous episode. In the makefile I've added 2 more packages which we'll see we'll need, or which come in handy especially when we have to take images from physical machines. One is parted, which gives me a reasonably easy way to figure out how a disk is partitioned even if it's using GPT. The second one is BC, so I can use it as a calculator without running around, okay, where's my pocket calculator, because when you need these things there's always all sorts of stuff around, but not the pocket calculator or whatever you actually need. And I've also added 2 more features to the installer script. Now you can't just only reboot a machine, but you can also power it off. Convenient for the notebooks. And another thing I've added, because that is a bit of a nuisance with the notebooks I use for the trainings, like these ones here, and that is if I store them for a couple weeks or months without battery installed, which is the way you should store them, they actually lose their real-time clock settings and their bar settings as well, but there's nothing I can do about that at this point. So I've also added a feature that I can say synchronize the hardware clock to an NTP server running on the install server machine. Okay, so here's our menu, And here you see I can now halt the machine, I can synchronize clocks, and the rest is all what we've seen. And there's our demo image. That demo image.lzo is something I forgot to delete. Whatever. Let's install that to the one disk. And of course this takes a bit of time to install, and like 4.2 seconds. Okay, now this is fast. It is partly fast because we write faster than any physical disk would do. 250 megabytes per second is simply because things are written to a virtual disk which is still cached in memory, and the data isn't all written to the physical disk I use. And if I was to install a physical machine, this would be something around about 100 or 110 megabytes on my training notebooks. Of course, if you have a high-end SSD, it might go up to something like 400, 500, provided you get things across the network as quickly. But even if I used my standard notebooks with their 2.5-inch old-fashioned disks, this would take about maybe 10 seconds, which is pretty nice. At this point, all I have to do is reboot the machine, or because these virtual machines are a bit of a pain to decide what to boot from, I first halt it, and once it has halted, I edit the virtual machine configuration and tell it to boot from the physical disk rather than from across the network. And now it should actually boot into FreeBSD. It's booting from hard disk, that's good. That looks like FreeBSD. And well, looks like our system might actually work. The one thing you want to check at this point is that new SSH host keys are created. You want to keep a bit of an eye on that, just to make sure, because if they don't, you have a problem with your image. Okay, there's some new keys being created, that's fine. And at this point we have a working image. Now there's one problem, and that's if I check the space on the file systems, or the ZFS pools in this case, but I can also check on the file systems. You see the entire size is only around about a gigabyte, despite the fact that we've given the virtual machine a 100 gigabyte virtual disk. So at this point we have a bit of a problem sort of thing, which is that if we want to use the entire disk, we have to resize things. How to do that if you want to use the entire disk is part of the next episode, but for my purposes, when it comes to test machines or for systems where you just install a base system in its own partition or volume group, and then have plenty of space in there you can use for applications, then you might want to consider using a somewhat bigger disk image and use that for installation, so you don't have to worry about resizing disks. For example, if I decided I'd use a 10 gigabyte disk image, that 10 gigabyte disk image would take about 100 seconds, 2 minutes roundabout to install. That's still pretty good. And even with Windows, which takes about 20 gigabytes of space, for my training setups I'd use a 30 gigabyte disk image, so there'd be 10 gigabytes of data that, or 10 gigabytes of free space people could use. Quite likely enough for most people in most trainings, and if they don't need it, you can resize things anyway. And resizing things after installation just to keep the images small is probably not the very best idea if you just need a couple more gigabytes to have a bit of leeway to do whatever you want on the system. More importantly, if you want to compress images which you should normally do in a lot of cases because it saves space on the install server and it saves network bandwidth if you have to install multiple machines. When you do that, you actually get images, compressed images, which aren't any bigger because empty space that's initialized to zeros compresses very well and doesn't need any significant space in a compressed image. That said, if we use not FreeBSD, which just extracts a tarball, but if you use something that actually writes temporary files onto the file system, then extracts things and then deletes those temporary files again, then there's a trick to make sure that the compressed images stay small. And that looks like this. Again, it's not necessary on FreeBSD, but generally speaking, what you can do is something like dd. Input file is def0, output file is junk. And you do something like block size, like 1 megabyte or so. You just create a file filled with zeros on your file system until it's full, which takes a couple seconds. The reason why I do this is because this junk file is very, very good to compress. If it's all just zeros, it compresses to next to nothing and makes the compressed images small. You may want to do this depending on the particular system you want to install. It works quite nicely. Of course, once the file system is full, you remove that file again. And now you could take an image that compresses quite nicely. Very simple trick, very convenient, very nice. One more problem, if you use disk encryption, which you should do on mobile devices, for example, that you actually use to store some sort of business data on, then using images can be a problem. Why is that? Because the way these disk encryptions work. You have a disk, and to encrypt it, first you add some sort of metadata, which holds some stuff you'll need, and then the encrypted actual data. And the metadata contains a randomly generated key, or normally one randomly generated key, which encrypts the actual data in your disk. And then you have a passphrase to encrypt this random key. Now, if you take an image from that system, aside from the fact that that encrypted data doesn't compress very well, and you install that to multiple machines, it means they all have the same random key. And even if you change the passphrase or key file or whatever that this random key is encrypted with, the random key is the same on all machines. So if you have a couple hundred sales reps running around with your fancy new Ultrabook things you've set up this way, if one of them screws up and somebody gets access to his or her passphrase, they can get access of the random key, which is the same on all notebooks, on all your sales reps notebooks, and so they can decrypt and manipulate all the other machines as well. If you want to install that using an install server, it's a bit more involved and it's beyond the scope of this series. It's possible. It's a bit trickier, and you don't get a chance really to use an install server that installs FreeBSD, for example, but itself runs on Debian in the rescue system. So that's pretty much all there is about it for what I do. So you see, it's nice and simple and fairly fast. But of course, things get ugly and tedious and complicated and troublesome if you want to do some of the more tricky stuff. And there's one more thing I want to show you in this episode, and that is how to deal with the situation if you actually have to take images from a physical disk. Now, the first thing you do, if you have, for example, these notebooks I have, they have a 300 gigabyte disk in there. Extracting or writing an image to those takes round about an hour if you want to fill the entire disk or have to read the entire disk. That's not what I really want. That's way too long for my purposes with the trainings, and it's quite a bit of time if you install a server, for example. And if it's not a 300 gigabyte disk but a 3 terabyte 3.5 inch disk, it takes 8, 9, maybe 10 hours, which is really painful. So what you can do is you install your system and you create a reasonably small file system at the beginning, and then only take an image of the beginning of the disk. And the trick here is to make sure that you get everything you need but nothing more. And that's where you can do some optimization, but there's lots of chance to really screw up, and most operating systems and most file systems don't take kindly to missing the last couple of blocks on a file system. So you want to be a bit more careful, and let's take a look at how I take an image from something that is only partially used. So back to our virtual machines again. In this system, let's clean this up first. Do a gpart show ADA0. First thing you see, by the way, is that GPT says this is corrupt. And what is corrupt? GPT has a copy of the partition table at the end of the disk. Because we've grown the disk, we've originally started with a 1 gigabyte image, now copied it to a 100 gigabyte image. This tells you something is wrong. What you can do is recover. This is FreeBSD, but you can do pretty much the same with Parted on Linux. And once we've done that, everything is fine. So now we have our GPT partition table, we've got a FreeBSD boot partition, and we've got a FreeBSD ZFS, which contains our actual file systems and the ZFS pool. And next thing we do is we power this off, and again modify our virtual machine, so we boot across the network again and start xen test. We boot into our rescue system again, and for this to work we need some place where we can write the disk image to. And what I've done here is I've created another NFS share, which I called service NFS incoming to the installed server, which is read-write mountable or read-write exported, but I've not used root squash or no root squash. So if I mount this on my target system and write something as root, it'll actually show up as owned by nobody and no group on the NFS server. Prevents a number of nasty security issues. And our rescue system boots, and now I can use another virtual console where there is no menu and log in as root. And now what I do is mount 10T552551 service NFS incoming to mount, and there's some leftovers there. And now I can copy a disk image there. Whoops. The tool of choice again is DD, and you say input file is dev xvda, output file is demo.image. You can also compress things if you like along the way. And okay, you do it something like block size equals 1024K or 1 megabyte, because that speeds up writing quite significantly. And if you do this, you write 100 gigabytes worth of stuff onto the NFS server, which is big, which takes some time, and just reading that stuff from a physical machine would take about 20 minutes, and writing that image to a physical machine takes another 20 minutes. So it doesn't make much sense, because out of those 100 gigabytes we've got on the, in this case, virtual disk, but let's assume it's physical, we only need the first gigabyte. And what you do here is normally do something like count equals whatever. What do we have to put there? We have to take a look at the partition table, and that's where things are getting a bit ugly. So I've installed ported and def xvda, and we can do something like print, and this is useless. Why is that? Because it shows the size in kilobytes and megabytes and whatever, and we're using block sizes of 512 bytes. So first thing we have to do is say unit B, and you say print again, and then we get the sizes in bytes. So what we could do is we could say we could copy blah 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 plus 1, because this is the last byte and we start counting from 0, so we have to add 1 to this. But let's work the numbers correctly. So we use BC, and we do 107.372.4928. That's the number of bytes that we actually need to save, because that's the end of the last partition. We divide that by 1 kilobyte, and what you see, we have a rounding error there, because we have an odd number of 512 byte blocks used in our image. So if we want to write this, we want to be really careful about that. And if we want to write in megabytes, we divide by 1024 again, and we get a value here which is not integral. So what we have to do is, in our dd command, round it up, 1024 megabytes, which is 1 gigabyte, and that gets us that image. If we wanted to compress it, we would do pretty much the same. Let's run this one first. All we have to do if we want to compress things is pipe this into our compression program of choice, and we see how long this entire thing takes. Writing a gigabyte across NFS actually takes a bit of time, especially when virtualization is involved and we're doing things on the same disk but in different areas. But even then, it takes, I think, 2 minutes or something like this. Okay, so here we are, and it took almost, or good 3.5 minutes, but this is pretty much the worst case, or the worst approach you can do. Actually treat this like a physical machine, so you have to go through the NFS server, while this is actually a virtual machine where you could just, you know, do something like what I've done before, like hang on, here we are, copy hd0.image somewhere. Now if you want to compress things instead, what you do is something like this. You don't give an output file, but instead you pipe the output to your favorite compression to gzip-9, output to demo.image.gzip, and I'm not going to run that because that takes even longer. Again, if we're using virtual machines, what we can do is we can use dd here to extract the beginning of the file. So we could do something like this. block size is 1 megabyte, count is 1024, and then we could do something like either OF rdh0.image.relevant, or we could do something like pipe, well, let's say LZOP -9 to image hd0.image.lzo or something like that. Plenty of options. There's always another way to hurt yourself. So that's pretty much all there is about creating images. And one more thing, maybe there's a good chance you install things twice. First to see how much space you actually need, and then install things on a suitable disk image again. Fine. After all, once you know how much you need, that's reasonable to reduce the image size. However, if you want to use images the way they are without resizing partitions afterwards, which I'll show you how to do in the next episode, then you might as well just say, okay, for Windows I'd use something. Windows takes about 20 gigabytes or so, or 30 gigabytes if you install from a rescue system and your hardware vendor added all sorts of bonus garbage to those images. For a standard Windows installation from a standard regular disk, Windows 7 takes about 20 gigabytes. Make that a 30 gigabyte image, and that installs in about 6 minutes, and you don't have to worry about resizing disk images. Most convenient for me for training situations. Linux generally around about a gigabyte, maybe 2 gigabytes. FreeBSD you've seen about 700 megabytes. And on FreeBSD you could actually trick things and compress parts of the ZFS pool if you really want to do that. Saves a bit of extra space, but doesn't actually make the compressed images any smaller, just the uncompressed ones. So that's pretty much all there is to creating images, and at this point you should be able to take whatever operating system you want, install it, set up an image, and get things done. The only thing left is what to do when you want to do things to a particular system, which you can do basically in two ways. One thing is we could add a post-install script sort of feature to our image installer, which could mount the system and then do all sorts of funny stuff, or not mount things and resize file systems. Problem there is, if the rescue system is running Linux and I install a FreeBSD image, that's getting rather tricky. Yes, there might be ways around using KVM or Xen or VirtualBox or whatever to do things, but that's really crazy. The other option is to do something that the first time the installed image on the target system boots, it does some extra stuff. That's extremely powerful. There are a couple limitations, however, but generally speaking that's really powerful, and there are a couple things you want to be careful about if you do this. So we leave that for another episode, which will be the last one on this installed server and rescue system series. But for my purposes, as far as the training environment goes, at this point I'm reasonably happy. And yes, I've already created a number of different images for different Linuxes, for FreeBSD, NetBSD, OpenBSD, for OpenIndiana and Windows 7. So as far as I'm concerned, I'm really happy with what I have at this time, and with the training environment, that's pretty much all I need. All I want to show you is how to do things in a possibly data center environment or such, where you need a couple more features later on. Anyway, we leave that to the next episode. For now, let's call it a day. I hope you liked this. If you did and watched this on YouTube, you do me a favor, give it a thumbs up. If you have questions, suggestions, and ideas beyond this, come over to the forum at www.stepladder-it.com/bivblog/17. And in any case, if you liked this or didn't, whatever, hopefully see you again soon. Bye.